Hello, I'm Steve Reyes, Product Manager for Animetsu Company, and in this video we're going to demonstrate how to calibrate the VectorStar ME7838G 220 GHz broadband system. The system is comprised of the VectorStar, which goes up to 70 GHz, but in this case is only going up to 54 GHz. And then we're driving the MA25400A millimeter wave modules, the nonlinear transition line modules, in order to get up to 220 GHz. So a typical application for this system is on wafer measurements, and therefore what we'll be demonstrating is how to perform a non-wafer calibration for this system all the way up to 220 GHz. So the system, again, is comprised of the VNA and the test set and these modules. And what we have mounted for now is the MPI probes, and we'll be using MPI calibration substrates as well. So the first place that we start is setting up the VNA for the proper parameters that we want to measure. And we start off with the frequency range. So here we have it set up for 70 kilohertz up to 220 gigahertz. And in this menu we can also set up for the number of points, and I'll just keep it to 201 points for now. And next we could go to power and set our power for both the low band and high band. So up to 54 gigahertz is the low band, that's set for -18, and above 54 we're also set for -18 to go all the way up to 220. And the same is true for port 2 in terms of the low band and high band power. So we're set for a -18 dBm broadband sweep from 70 kilohertz to 220 gigahertz. Then the final thing we'd want to do is go to our channel menu, select averaging, and verify the IF bandwidth is about where we would want it to be. In this case, I have it set for 300 hertz. You can set it for whatever bandwidth that you want, depending on how low of a power level and the dynamic range that you're looking for. Okay, so that sets up our frequency, power, and averaging. Next, we'll go to calibration and start setting up for that. And in our calibration menu, we can go straight to calibrate. There are other options here that sometimes you might want to take advantage of. For instance, de-embedding tools. So if you have fixtures that you may want to de-embed during this whole measurement process, we have a wide range of network de-embedding tools, both standard and the UFX option, which goes into further description of the networks where you may not have a full range of calibration standards available. So the universal fixture extraction option will help you out in that whatever you have in terms of information on a standard, say a short for instance, if that's all you have, then you can input that in, and an S2P file will be generated, taking on other certain assumptions in the calibration in order to incorporate that short information into your S2P de-embedding network. So in any case, if you have those types of things that you want to set up, this is where you would do it in the calibration. So we can go back to our calibration menu and enter calibrate, since we won't be doing any de-embedding in this video. So we go to calibrate, and now we have a few choices. This is going to be a manual operation, and so we'll go to manual calibrate, and here's where we define the type of port configuration. In this case we'll be doing 2-port calibration, so we select that, and this is where we can actually start to measure the standards that we have on hand. But before we do that, we want to make sure that we're set up for the types of calibration that we want in this broadband on wafer measurement. So we'll go first to modify Cal Setup, and this is where we define the type of calibration, the algorithm that we're going to be using. And so if we had a coax setup, then one of these would apply. They would also apply in other situations. Okay, so now that we know we have enough information on our calibration substrate, we can start to enter those parameters into our configuration panel here. And we start off, first of all, defining whether or not we're going to locate our reference plane at the end of the line or in the middle of the line. And if we know that our DUT is located at the equal distance of half the length of our through calibration standard, then we can choose middle of line, and that will automatically then locate the reference plane to the port of the DUT rather than include the line from the pad to the DUT. In this case, we're going to use end of line, and so now we'll be calibrated at the ends of, or at the tips of the probes, and we'll then be measuring everything from the pad along the transmission line to the DUT and include the DUT measurement. So we've selected the end of line here. The length of our calibration through is then defined here either by effective length, by the delay, or the physical length. And we have selected effective length in this representation. And then down here is where we define the number of bands we'll be using and the types of devices. So if this were LRL, then we would have two lines, a line and a second line, and then a reflect. So our first line is our calibration through, and it's 182 micron length, effective length, and that's what's entered here. Our second standard is a match, so we'll change this to the match, and now you see we have the opportunity to input more information about the match. And so if we go into this panel, we can then set up the parameter for the match based on the information that we have. In this particular case, we know that the load is delayed by 16 micron, and that's what's entered here. And we have then, therefore, our additional information that defines the match for both port 1 and port 2. Okay, so if you have other types of information, you can enter it here as well. All right, so now our match is defined properly, and we just now want to determine what type of reflect that we're going to use, either an open or a short. It doesn't have to be perfect, it's just an open like or short like. You can also include both, so you can include two different reflection types. That's our advanced LRM capability. In this case, we'll just be doing the short. And now to finalize the description of the standards we're using, we can enter the offset lengths for the open and the short. And in this case, it's 16 micron length to the shorts and the opens, and that's what's entered here. And so now we're set up. We have all the information we need that defines this calibration substrate. We'll click OK, and then go back to our calibration menu. So now we're ready to mount our calibration substrate, and before we actually set up the whole system, we'll want to make sure that we understand the calibration substrate and the parameters that we need to enter. Usually what we'll have is a pictorial layout of the calibration substrate with the information that we need in terms of the delay lengths and any other parameters that define the standards. So once we have that, then we can go ahead and mount our substrate onto the calibration chuck. So in this case, for the MPI TS200, we have a separate ceramic mounting chuck for the calibration substrates, which greatly helps in properly defining the standards rather than locating it on a metal chuck. So we mount that and set it up and get ready for the measurement of the standards. Okay, now we have the calibration substrate mounted, and first thing you want to do is check for the theta, and so we can adjust the chuck to get our theta of the chuck in decent location. Then we can start to touch down on some of the standards. And so now we can zoom in on the short here and bring in our probes. In preparation for a touchdown onto the short. Now on the station, we have a capability of raising and lowering the platen. And so at this point, I'll bring the platen down so that we start to get closer to actual touchdown, and then drop it so that we're in our contact position. That freezes the chuck. And so now we can do our final adjustments to the probe location in order to make our touchdowns. So what's helpful here is having good visibility of the probes so that we can see exactly where we're going to be touching down on the pads. There we are. And we do the second one for port 2. So now we can measure the short for port 1 and short for port 2. So next is the line and match menu, and group of standards. So here is where we can just do a quick probe up location and then go to our next set of standards, which in this case will be the match. So now we'll be able to go to our match and touch down on port 1 and port 2. And make our measurements. Okay. Lift our probes and now go to our line. And touch down on our line. Make that measurement. And now we can click done and start evaluation of our calibration. So trace 3 is now showing a measurement of the calibration through, which of course is going to look, excellent, because that's what we're using as our standard. So you can see with the proper calibration substrate, the calibration of the ME7838G 220 gigahertz system, the VectorStar Broadband system, is very similar to our other broadband systems, and doing a calibration at 110 gigahertz or 220 gigahertz, it's still the same process of having a calibration substrate where you can do, for instance, an LRM calibration and get very good results over the entire frequency sweep in a single sweep measurement. And so, using the system in the proper setup with the ME7838G system can give you a wideband calibration from 70 kilohertz up to 220 gigahertz in a single sweep measurement. So I hope that was helpful in understanding how we do a calibration with our VectorStar 220 gigahertz system. Thank you.